Hello everyone. In this video, we're going to talk about mean value theorem and summarize it because I know it's kind of a lot, kind of different. You might still be wavering in the air about it. Hopefully this video helps sum up mean value theorem. So what is mean value theorem? So informally, mean, if you understand from statistics, means average. And what the mean value theorem is basically saying informally, it's always saying that the average must occur. Now, the idea formally is you have to talk about continuity and differentiation depending what you're looking at, but more or less the idea is that the average must occur. Right? And there's two, this is maybe where some of you are stuck on, is mean value theorem, which is also abbreviated MVT. There's two parts to it. Is we could talk about average value of a function. I spelled that wrong. Rewrite that. Average value. Or you could even look at the average rate of change of a function. So there's two parts to it. Not that one's better than the other, but two ways of understanding it. Average value and average rate of change. So let's look at examples of each of these. So for average value, 1. So let's say we are given, so for the function f of x, which is equal to x squared, we'll keep it simple, the parabola. And we're going to look at on the bound, say z, we'll do 1 to 4. Okay. Show, or let's even do this. For f of x equals x around 1, 4, when does the average value occur? Okay, so that's our question. Let's split this down my page. Okay, so visually, to help you remember this, visually we have x squared, which is a parabola. Okay, and we're going from 1 to 4, where I know at 1, it's at 1. And I know that at 4, 4 squared would be 16. Okay, so what's your average value? Well, if you understand average, let's think about this. Well, what's the value? Well, in the very beginning, the value is 1. And at every moment along the way, the value is changing. But the idea is on this interval, what is the average value? It's not necessarily in the middle, because it might have been lower for a longer time than it has been higher. In this case, maybe it looks kind of symmetric here, but if the curve had a different shape to it, where, say, for example, it's low for a long time and then it shoots up, and you say, what's the average value from here to here? Say it even shoots up faster. The average value might end up being lower, where you can't just look at the middle because it was lower for a longer time before it was higher. So the idea is like all these little moments. So average value, now think about how you find average. If someone says find the average of these two numbers, how do you find averages? You always add it up and divide by how many there are. Well, if we're talking about average value, we want to know what are all the values here. We want to add up every single value. Well, how do you add up every value from 1 to 16? All these, how do you add up all the y values? Well, we integrate it. We want to know what's all the value y values. We're going to integrate it or sum up, even remember, because that's like the sum or the add up. We're going to add up all the values of f of x on 1 to 4. And once we add up all the values, think about how you find average. You add it all up and then you divide by how many there are. So we're dividing from 4 to 1. And there's your average value. And then we just have to calculate it. So if we do this out by hand, we're doing 1 to 4 of x squared dx. And that will add up every value along here, every y value. Infinitely many y values, that is. And then we're going to be dividing by 4 minus 1. So the integral of x squared is going to be x to the third over 3. We'll get value from 1 to 4. Now I'll be dividing by 3, which that's going to give in my space here, that's 4 to the third over 3 minus 1 to the third over 3 divided by 3. And you end up getting here 4 times 4 is 16, 64 over 3 minus 1/3 over 3, which is 63 over 3 divided by 3, which is the same as timesing by 1/3. So that ends up becoming 63/9. And then if you simplify that, divide top and bottom by 3 at this point, you get 20. Well, wait, 63 divided by 9 is 7. What am I doing? So then you get 7. No, is it 7? Yeah, it is. Yeah. My brain is eluding me. And we could have got that there because 63 divided by 3 is 21. 21 divided by 3 is 7. So 7, and I don't know if you saw that. So what is 7? 7 is the average value. Now we're not done with the question. The question says, when does it occur? Okay, so 7 is the average value. So visually, at 7, that's your average value, right there. Let me draw the average line. So there's your average value. Now, when does it occur? Well, when does x squared equal 7? That's the idea, is when does x squared equal 7? When does that curve equal 7? Solving for x, we're going to get x is going to equal the square root of 7, which is approximately, if you put that in a calculator, 2.646. In which the big thing you have to notice is, how does that satisfy the mean value theorem? Remember, mean value theorem is basically saying the average must occur. This happens at 2.46. So at 2.646, f of x hits its average value of 7. And notice that 2.646 is in your interval 1 to 4, because again, it must occur in that. And there's average value. Now, what about average rate of change, the second part of this? So let's say a similar problem. Let's do for f of x equals x squared on 1 to 4. And the question is, when does its average rate of change occur? Okay, what if that's the question? And you'll see that if you understand the question, what you're trying to do, don't try to memorize which one to use. Do I use integrals? Do I use derivatives? Because that's often what I've seen students say. Understand what it's doing and use the appropriate path, as that approach will take you a lot farther using what you need in the moment than trying to memorize it. So if we think about rate of change, so visually, let's draw this out again. Here's your parabola from 1 to 4. Okay. Now, what is rate of change? So rate of change visually is the slope. So really what this is saying is, when does the average slope occur? Well, what's the slope from 1 to 4? So basically, we're saying, okay, what's the slope from 1 to 4? Where that's at 1 and that's at 16. So what's your average slope? Well, average slope is the same thing as, people might call it the slope of the secant line. It's fancy. That's secant line is just because it crosses the line twice. That's all it means. It hits twice. It's just fancy language. But what's the slope of this line? Well, how do you find the slope of a line? The slope between 2 points is, you're just finding the slope between the points 4, 16 and 1, 1. So we can do 16 minus 1 over 4 minus 1, the whole y2 minus y1, or x minus x1, or change in y over change in x. And what we get here is 15 thirds, which is equal to 5. So that means here that the slope of the average slope is 5. The average slope is 5. Now the question again is, when does it occur? Well, if mean value theorem holds, which you'll see that it always does, it should be between 1 and 4, assuming it's continuous, and in this case differentiable. And you'll see why in a second. So when does it occur? So we want to know, when is the slope at a particular moment going to equal 5? Well, what's the slope at a particular moment? If you want to study moments in time, as if you can freeze time and look at how are things changing, well, that's the derivative. So what that's saying is, when does the derivative, when does f prime of x, because again, that's your instant slope, instantaneous slope or rate of change, when does f prime of x equal 5? That's what it's asking there. And note, so now we're going to need to use the derivative. So what's the derivative of f of x? Well, f prime of x is going to give us 2x. So when does 2x equal 5? At 5 halves. So at 5 halves, which is right there, the instantaneous rate of slope will be the same. Now, you might not see it very well visually, so let me do a zoom in to wrap this up. A zoom in of this. So zooming in is, there is a curve here, all right? And I'm making it much more drastic to have the effect. and here's 1, 1, and here's 4, 16. So we said that the slope of this line, the slope is 5. And what we found is that at 5 halves, wherever that's at, say it's right here, at 5 halves, what's the slope at that moment? The instantaneous rate of slope? Well, it's also 5. And notice that there are parallel slopes because, again, they're parallel or the same rate of change. The instant rate of change is the same as the average rate of change. So that's how mean value theorem works. And you can see it's really 2 parts, and I don't want you to memorize when I use integrals, when I use derivatives. Just understand what you're trying to do. All right. Average must occur. Average value, well, you want to add up all the values, which is an integral. Average rate of change is we're looking at slope, and to find when it occurs, we need the instant slope. All right. And you could read the book on the formal definition of it, but this is really how it works. Okay. I hope that helps. So that's mean value theorem and applying it. If you have questions, just be sure to reach out and contact me or peers, and we can keep working on it. All right. Take care. Bye-bye.